Hello everyone. Now we will see another concept in complex numbers, that is conjugate of complex numbers, and very important. And we get lot of questions on this concept in complex numbers in mains and entrance exams. So what is this conjugate of complex number? Okay. Now we know a complex number is represented by z is equal to a plus ib. Okay. Now conjugate. Okay. Now actually Z means always remember. See, Z means it's a small letter. A plus I. Because we have capital letter Z which is set of integers. Okay. Now complex number small z equal to A plus I. Okay. Now the conjugate of complex number is by changing. Okay. Conjugate of complex number. Conjugate of complex number is obtained by changing the sign of its imaginary part. Very simple. See, imaginary part sign is changed. That's all. Suppose if my z is equal to a plus ib, the conjugate is represented by z bar. So z bar is conjugate of z. Z is a complex. So that means if z is equal to a plus ib, so z bar will be, now change the sign of the imaginary part, which will be a minus ib. A minus ib. That will be your z bar. Very simple. That means change the sign of the imaginary number. Change this sign. Instead of plus, change. Suppose if z is equal to a minus ib, z bar will be a plus ib. A plus ib. So that is how the conjugate will be. Okay. That is how the conjugate will be. Now in an organed plane. Okay. Now we have seen in my last, who haven't seen the video, just you can watch that. So my organ plane now, suppose if z is this one, okay, if z is this, okay, if z is a plus I, what will be your z bar? Z bar will be a minus ib. That means where it will come now? This is your positive x-axis, this is your negative x-axis, which is your real part, your positive y-axis, which is your imaginary part, negative y-axis, which is your negative imaginary part. Now here your real part is positive, your imaginary part is negative. That means where it will come? Your real part, this is your real part is positive, imaginary part is negative, this is your imaginary part. That means like this. So this will be your this will be your so this will be your conjugate complex. So this will be your z is equal to z bar. Okay, z bar equal to a minus. Okay, like that you can represent. So if z equal to a plus ib, this is what actually. Okay. Now let us see some properties. Okay, some properties. Now I have z. Now I have z. Z is equal to x plus iy. What is your z bar? X minus iy. Now what is your z plus z bar? Which will be your x plus iy plus x minus iy. So iy gets cancelled, which will be equal to 2x. That is nothing but 2 real part of z. X is what? X is the real part, right? We have seen x is the real part. X is the real part. So real part of z is x. Imaginary part of z, y. Okay. Now the same now z minus z bar, which will be x plus iy minus of x minus iy, which will be x plus iy minus x plus iy. X cancels. 2iy. What is 2iy? 2iy is how much? It is nothing but 2y into imaginary part. Imaginary part of z. Y is imaginary part of z, right? 2y into imaginary part of z. Okay. Now similarly z bar. Z into z bar is how much? Z into z bar is your x plus iy into x minus iy. This we have seen already, rationalization. So your x square minus I square y square, which will be x square plus y square. X square plus y square. Okay. Now we will see some more properties. So z bar of z bar. That means I have conjugate, again conjugate. That is nothing but z. So what is your z? X plus iy. Your z bar is x minus iy. Now z bar whole bar means x minus iy whole bar. That means I have to change the sign of this imaginary number. That is x plus iy, which is again z. That's what I was getting. Okay. Similarly, conjugate of z1 plus z2. So I have conjugate of z1 plus z2, individual of z1 plus z2. We can take like this. Similarly, conjugate of z1 minus z2 will be z1 minus z2 individual conjugates. Okay. Now conjugate of z1 z2 is equal to z1 conjugate z2 conjugate. So that means in general, if I was conjugate of z1 z2 zn, I'll get z1 z2 so on zn conjugate like that. This is in general. Till n, z1 is one complex number, z2 is another complex number, z3 is another complex number like that. Okay. Now if I have now z1 by z2 whole conjugate, this whole conjugate. So this will be now z1 conjugate by z2 conjugate. Provided z2 should not be equal to 0, because your denominator, if it becomes 0, it will be infinite. Okay. Now, just see this. Now we'll go to the some examples. We'll see one example. Now I have now z1 imaginary of z2 bar z3 plus z2 imaginary of z3 bar z1 plus z3 imaginary of z1 bar z. Okay. So where z1, z2, z3 are complex numbers. Complex numbers. Okay. Now you see. So how I'll solve this? How I'll solve this? Now, before solving this, let us see one simple from these formulas. From these formulas, can we derive any other alternate formula to solve this kind of problem? That we have to see. Okay. Now you see here. Here I'm having imaginary of z2 bar z3 bar. Now suppose I have a complex number. Let us think like this. Z is equal to x plus i1. Think like this. Now, what is your z bar? X minus i1. Right? Now, imaginary of z. Now, let us do like this. Now, z minus Z bar. You subtract it. How much I'll get? X plus Iy. X cancels. I'll get 2Iy. What is your y now? 1 by 2i of Z minus Z bar. Right? What is y actually? Imaginary of Z. Imaginary of Z is your y. So that is equal to 1 by 2i Z minus Z bar. Remember this formula. This is, remember this formula. Remember this formula. Imaginary of Z is equal to 1 by 2i into Z minus Z bar. Now now with this can we solve these parts? Okay. With this can we solve these parts? Now here you see. Now you see. How I will write like this? You just let me go to the other or I'll write here. Okay, I'll go to the other window so that I'll write clarity. Now you see here. Now if I open here this, so Z1 imaginary of Z1 imaginary of Z2 bar Z3 plus Z2 imagine. I'm writing the again the question here. Z3 bar Z1 plus Z3 imaginary of Z1 bar Z2. Okay. Now we know we derived this in the green box. If you see, imaginary of Z is equal to 1 by 2i Z minus Z bar. Okay. Now is clear. With this, so this is we know. This we got. We know this. Now we have to solve this. Now, what is like we have seen now in the earlier things. See, now if I have imaginary of Z is equal to 1 by 2 into Z minus Z bar. Now, what is your imaginary of Z bar? Imaginary of Z bar. You see, your Z is equal to X plus Iy. Z is equal to Z bar equal to X minus Iy. Right? Now, imaginary of Z will be Y. Imaginary of Z bar will be minus Y. That means that is equal to minus imaginary of Z. Minus imaginary of Z, right? This is equal to minus imaginary of Z. This is our imagine of Z. Okay, fine. Now let us solve this. Z1 imaginary of Z2 bar Z3. Now you see here. Now can I write like this? What I'll do is, here first I'll solve this one. Z1 into imaginary of Z2 bar into Z3. How I will write? Now imaginary of Z is this one, 1 by 2i into so now I'll take now Z1. So Z1 into, see, imaginary of Z2 bar Z3. See, this is also one complex number, right? Z2 bar Z3 is also one complex number. Now, imaginary of Z is how much? 1 by 2a into Z minus Z bar. Now, think like this. This entire thing, Z, this one bar Z2, Z3, this is one complex number. Now, I can write this imaginary of Z2 bar Z3 is 1 by 2i into, in place of Z, put this Z2 bar Z3 minus. Now, in place of Z conjugate, now reverse conjugate now. Z2 Z3 conjugate. That's what, see, imaginary of Z. Imaginary of Z is this one. Okay, imaginary of Z is this. Now, in place of Z, I am writing Z2 bar Z3 because this is also one complex number, because two complex numbers product is again a complex number. Okay. Now, what I am doing now, the formula for imaginary of Z is 1 by 2 into Z minus Z bar. Now, in place of Z, what I'll write? Z2 bar Z3. This I will write. Minus, in place of Z bar, what I'll write? Reverse the conjugate now. In place of Z, so now it will be Z2 minus minus Z2 Z3 bar. Okay, now this is what. Now, plus, what is that now? Z2. Z2 into, again it is 1 by 2i into Z3 bar Z1 is how much? Same. Z3 bar Z1 minus Z3 Z1 bar. Okay. Plus Z3 into 1 by 2i into Z1 bar. Z1 bar Z2 minus Z1 Z2 bar. Okay. Now you take 1 by 2i common. Now if I take 1 by 2a common, it will be now Z1, Z2 bar, Z3 minus Z1, Z2, Z3 bar. Okay. Next is plus Z2, Z3 bar, Z1 minus Z2, Z3, Z1 bar plus Z1, Z2, Z3. Sorry, Z1 bar, Z2, Z3 minus Z1, Z2 bar, Z3. So this cancels. Okay. Okay, Z1 bar. Anywhere Z1 bar is there? Yes. Z1 bar, Z2, Z3. This cancels. Next, Z2, Z3 bar, Z1. Okay, this also cancels. Everything will be 0 now. 0. That's all. 0 by 2 is 0. That's all. This is the answer. So you see, we have to think like this. So imaginary of Z is 1 by 2 into Z minus Z bar. Now in place of Z2 bar Z3, I am writing, I mean, wherever Z is there, I am writing this Z2 bar Z3. So now it will be now Z is nothing but your Z2 bar Z3 minus Z bar is nothing but reverse the conjugate Z2 Z3 bar. Like that. Like that you do for the other, you will get 0. Okay. Now we'll see one more concept called modulus of complex number. Modulus of complex number. Modulus of complex number. So if I have Z is equal to X plus IY, modulus of Z is determined mod Z, which will be equal to square root of X square plus Y square. So this is called modulus. This is determined modulus of Z. Okay. Now there will be some questions like find modulus of complex number root 3 plus 1 by 2 root 2 minus I root 3 minus 1 by 2 root 2. So this will be equal to square root of root 3 plus 1 by 2 root 2 whole square plus root 3 minus 1 by 2 root 2 whole square. Because this is in the form of x. This is your x. This is your y. See, you have to take minus also into consideration. Minus. So it will be your minus. Okay. Minus of whole square will be plus only. Okay. So now if you write, so it will be 2 root 2 whole square will be 4 into 2. Next will be root 3 plus 1 whole square plus root 3 minus 1 whole square. Right? Square root. Square root. So how much it will be? Just simplify this. So 3 plus 1 plus 3, 2 root 3 plus 3 plus 1 minus 2 root 3 whole divided by 8. 2 root 3, 2 root 3 cancel. 3 plus 3, 6. 6 plus 1, 7. Root of 8 by 8, which is 1. Yeah. Like that, you will have some questions. So the next topic we are going to see is argument of complex number, which we are going to study in the next session. Thank you all.